Okay, let's take a look at section J22, which is a review of multiplying and dividing rational expressions. Okay, multiplying and dividing rational expressions is the same thing as multiplying and dividing fractions. Okay, so remember when we multiply, we just multiply straight across, right, on top and bottom. So to show you an example, if we had something like, I don't know, 1/2 times 4/5, okay? If we multiplied those, we would just multiply tops. So 4 times 1 is 4, right? And on bottom we have 2 times 5. And once we multiply straight across, then we can go ahead and reduce, right? So I could say 2 goes into 2 one time, 2 goes into 4 two times, and then that leaves me with 2/5, right? So we multiply straight across, and then we reduce by common factors on top and bottom. When we divide, we first have to flip the second, right? Using our space gun. Did I tell you about the space gun? When you pinch the two dots together, right? Shoom, shoom. And it makes the second one flip. So we're multiplying by the reciprocal of the second, okay? Whenever we divide, we multiply by the reciprocal of the second. So we flip the second one. And then we just multiply straight across like we did here. Okay, so if I want to do an example of that, if I did say like 1/2 divided by 5/6, it's hard to say, then my space gun flips, right, the second one. So I'm going to do 1/2 times the reciprocal of the second. So we flip and get 6/5, and then we multiply straight across. So I get 6 over 2 times 5, and then I can reduce. And of course you can go ahead and multiply this and get 10 and then reduce, but I'm leaving it like this just because I know it does reduce. 2 goes into 2 one time, 2 goes into 6 three times, so I have 3/5 as my solution. Okay, so I want to apply this same idea to rational expressions. Okay, so if I am multiplying, I do want to multiply straight across and then reduce. Now, in order to reduce, everything has to be fully factored. So I'm actually going to factor everything first, okay? Factor everything first, okay? So if we factor everything first, then it's really easy to see if we have any common factors to reduce. So looking at this one, let's look at the top of the first rational expression. We have a squared minus 4. A squared minus 4 is actually a difference of squares, right? Oops, just hit my paper. Is a difference of squares. Difference of squares, right? Because my first base would be a, right? This is the same thing as a squared minus, and then my second base would be a 2, right? 2 squared. So difference of squares tells us that this is going to factor into the first base plus the second base times the first base minus the second base. So I'm going to go ahead and rewrite that as a plus 2 times a minus 2. Okay. So that's the top of the first expression. And then 16a on the bottom, that doesn't reduce at all, right? That's just a monomial, so we're just going to leave it as 16a. And then we're going to multiply it by our next one, okay? So if I look at the next term, 20a squared is a monomial, so we can't do anything with that. And on bottom, we have a plus 2. That is 2 terms. It's not a sum of squares, which wouldn't be factorable anyways, and it's not a sum of cubes, so there's nothing we can do there. There's no greatest common factor. But I am going to put parentheses around it just because that helps me see that this is a unit. This is one quantity that goes together. Okay. So now that I'm multiplying, I can just multiply straight across. Okay, and I'm going to shorten this. So if I multiply straight across, that gives me, and when you multiply straight across, anytime you have a monomial, we like to write that out front. So I'm going to write out my 20a squared and then my quantity a plus 2 times a minus 2 all over. On bottom, we have 16a times a plus 2. Okay, and now that we have it all as one fraction, we can go ahead and cancel anything they have in common on top and bottom. So my a's plus 2 will cancel, right? And then on top and bottom, I have 1a down here and 2 a's up here. So if I have 2 a's on top and 1 a on bottom, I can cancel 1 on top and bottom, right? So I'm going to cancel this one by just marking out the exponent and cancel that one. The other thing I notice is that 20 and 16 I can also reduce. 16 doesn't go into 20, but they're both reducible by 4, right? So I'm going to go ahead and I'm just going to write an extra step in here. Okay, so I have 20a times a minus 2, and on bottom I now just have a 16. Okay, I'm just going to come down here so this part didn't get too messy. So all I did was take away all the stuff I marked out, right? So now I want to reduce these two. So 20 is the same thing as 4 times 5, right? And 16 is the same thing as 4 times 4. So I can actually reduce by 4 on top and bottom. I'm going to mark out my 4's, okay? Which leaves me with 5a times the quantity a minus 2 on top. And on bottom, all I'm left with is 4. So we're going to leave it like that. Okay? Not too bad, maybe? All right, let's look at another one. Same idea here, except it's a division. So I still want to factor everything, but then don't forget when we divide, we have to flip and do the reciprocal of the second. Okay? So let's go ahead and factor this out. This top one, x minus 2, there's no x squared, no x cubed. It's just x to the first power. So I can't factor this unless there's a greatest common factor, which between x and 2, there's not. So I can't do anything there. On the bottom, 12, that's just a constant term, right? That's just a monomial. Can't do anything there. So let's go ahead and look at this guy right here. This guy is a trinomial. So I'm going to use the sum product chart, but always make sure you check for greatest common factor first. Here I don't have a greatest common factor, so I'm going to go ahead and say no GCF, and then I'm going to go ahead and do my sum product chart. Okay, so my sum product chart says that my sum is my middle coefficient, which is a -4, and my product is my first coefficient times my last. So my first coefficient here is a 1. So 1 times 4 is 4. What can I multiply to get 4 that I can combine to get -4 would be -2 and -2, right? Or -2 minus 2. And notice the cool thing about this is that my leading coefficient's a 1. Yay! So that means we can use our shortcut. So that means this one factors into x minus 2 times x minus 2. Okay? And then I need to look and see what this one I can do with. Okay? What I notice is that I have a greatest common factor, right? So my greatest common factor here is going to be 3x squared. So I'm going to write the 3x squared that I'm going to take out. And once I take out 3x squared, that's going to leave me with the first term. I'm just going to have an x left. And out of the second term, my x's are gone, but 15 divided by 3 leaves me with a positive 5. Okay? Okay, so now let's rewrite this mess now that we have everything fully factored. Okay? So the first expression we didn't do anything with, right? X minus 2 over 12 divided by, on top here, we know that this guy became x minus 2 times x minus 2. X minus 2 times x minus 2. And then the bottom of the second expression became 3x squared times x plus 5. Okay, so now we have our division and everything's fully factored, but we cannot reduce, right? We have to be in a multiplicative state, okay, before we can do any reducing. So when we divide by a rational expression, that means we flip and multiply. So x minus 2 over 12 stays the same, right? But then when I divide, I use my space gun, shoo, shoo, right? And it flips it. So now I'm multiplying by 3x squared times x plus 5 on top, and x minus 2 times x plus 2 on bottom. Okay? And you can go ahead and start reducing here, or if you prefer, you can go ahead and write this all together in one fraction. Okay, so I'm going to write my monomial out front, right, because this is a quantity. So I have 3x squared times the quantity x minus 2 times the quantity x plus 5. On bottom, I have 12 and then x minus 2 and x plus 2. Okay, so once I get it all written together, then I can go ahead and reduce. So I have my x minus 2 quantities, and then I have my 3 and my 12, right? 3 goes into 12 4 times. So what that leaves me with on top is I still have an x squared, okay? And I have the quantity x plus 5. And on bottom now I have the 4 and I have the x plus 2. Okay. Why do I have a plus 2? Oh, because I rewrote it. I'm sorry. Caught my boo-boo. So over here we had an x minus 2 times an x minus 2. And whenever we changed it from a division to a multiplication, when we flipped this, I accidentally wrote a plus. So I apologize. This should be a minus, which means this should be a minus, which means this should be a minus. There we go. Now I feel better about it. Don't you feel better about it? All right, so let's go ahead and box that in. All right, so those are the only 2 examples I'm going to do, and then I'd like for you to try some. So I believe there are 3, yes, 3 on the next page for y'all to try. Now these may take a little bit of time, right? Because there's a lot of factoring involved, a lot of patience here. So take your time, work these out. If you get stuck, unpause the video, or if you are able to get through all of them, that's great. And then unpause the video to check yourself, okay? Okay, how did it go? Are we okay? All right, let's look at the first one. First one, there wasn't a whole lot to do, right? The only thing that we could have factored was the top of the first expression, which happens to be a difference of squares, right? My first base is an m, my second base is an n, so that's going to factor into m plus n times m minus n, okay? And then all the other terms stayed the same. There was nothing I could do to reduce any of those. But since it's a division, I have to flip and multiply by the reciprocal. So I'm going to change this to a multiplication and flip this one upside down. Once I flip that one upside down and we're in a multiplicative state here, now I can go ahead and just start reducing, okay? So my r plus s's cancel and my m minus n's cancel. So I should just be left with m plus n. Okay, everybody okay on number 1? Hopefully. All right, so let's look at the second one now. Number 2, a lot of factoring. Sorry. Everything on this was able to be factored. So let's start with the top of the first expression. So the top of the first expression does not have a greatest common factor. So we go straight into the sum product chart. Our sum is our middle coefficient, and our product is our first coefficient 4 times our last coefficient 2. Okay, so we need something that multiplies to 8 that combines to 9, which would be 8 and 1. Because our leading coefficient's not a 1, we have to not do the shortcut, unfortunately, right? So if there's no shortcut, we take the numbers from our chart and we replace the middle term and do grouping. Okay, when we do that, our top one should factor into x plus 2 and 4x plus 1. Okay. So we're going to go ahead and put that over here. I'm sorry, I already marked it out, but so this is the top of the first expression we're putting here, okay? The bottom of the first expression has no greatest common factor. I can factor it with sum product. So our middle coefficient is a 1, and our product is our first times our last coefficient. So our product's negative 2. So I can use 2 and negative 1 to multiply to negative 2 and combine to positive 1. And because my leading coefficient is a 1 down here on the bottom, that means I can use the shortcut on this one. So this one should factor into x plus 2 and x minus 1. So I'm going to write that as the new denominator of my first expression. Okay, so I'm all done with this one now. Now I need to look at this one. So looking at the top, I can see that this one is a difference of squares. Right? X is my first base, 1 is my second base. So when I factor that, it's going to be x plus 1 and x minus 1. Okay, we've done enough difference of squares. Hopefully we're starting to be able to recognize those pretty good. Okay, and then this bottom one, I am going to have to do some product, and there's no greatest common factor. So I kind of drew a line to do it down here. So our middle coefficient is a 1, so that's my sum. My product is my first coefficient times my last coefficient. So 3 times negative 2 means I have a product of negative 6. And I'm actually going to use 3 and negative 2 because that's the pairing that gives me a product of negative 6 and a sum of 1. And there's no shortcut, unfortunately, on this one because my leading coefficient is a 3. So I do have to take those two numbers and replace that middle term. Okay, so I have my 3x squared, and then I put in my two new values that I got from the chart, and then I have my minus 2, which was my constant term. Okay, after grouping, we can see that this one factors into x plus 1 times 3x minus 2. Okay, so in terms of this one, on top we have the difference of squares, x plus 1, x minus 1, and now for the denominator we have x plus 1 and 3x minus 2. So before I started like multiplying these together, I noticed right away I have the same quantity on top and bottom. So I went ahead and marked that out. And over here within this rational expression, I had the same quantity on top and bottom. So I went ahead and marked those out, and then I just multiplied what was left over. So I had 4x plus 1 times x minus 1, right? And then x minus 1 times 3x minus 2. So that's what's here. And then I noticed, oh, I have another matching quantity on top and bottom. So once I reduce those, then I end up with 4x plus 1 over 3x minus 2. Okay, how'd you do? Did we survive that one? That was kind of rough. All right, but still, everything we know how to do. We know how to multiply and divide fractions. Now we're just adding factoring into the mix because there's polynomials in the top and bottom. Okay, let's look at our last one, number 3. So number 3, when I look at the first expression, I'm going to have to use some product to factor both the top and the bottom. Okay, on the top, we have a sum of -1 and a product of -2. And the good thing about this is once we find our numbers, which in this case are -2 and 1, our leading coefficient is a 1, so we can use our shortcut. Same thing on bottom, right? Our sum is -1, our product is -6, and because we have a leading coefficient of 1, once we figure out the order pair that gives us or that satisfies that sum product chart, we can use the shortcut to go ahead and factor it. So hopefully this one's a little bit less time consuming for you to work out. So here's the top of my first expression, here's the bottom of my first expression. Okay, so I went ahead and wrote those over here. And then we look at our second one. The second one on top, it almost looks like a difference of squares, but notice this is not a perfect square here, right? That only has one a. So I can't do plus minus different squares formula. Okay, here the only thing I can do is take out a greatest common factor, which what they have in common is an a. And once I take out the a, I'm left with a minus 2. So I went ahead and replaced the top of my second rational expression with its factored form. And then the same thing on bottom. On bottom, this is not a sum of squares. This is not a sum of cubes. All I can do is factor out an a. When I factor out an a, I'm left with 2 plus a. So I went ahead and wrote that down here. So I have everything factored top and bottom of both expressions, but I can't reduce yet because it's a division. And when we divide, we flip the second one and multiply by the reciprocal. So the first one stays the same. I change this to a multiplication, and then I flip this one upside down. Okay. Once I do that, then you can start canceling out anything that's common on top and bottom. So we should be left with just a plus 1 and a minus 3. All right. So that is the end of section J22, which is multiplying and dividing rational expressions. So you should now be able to complete that homework assignment. If you need any help or have questions, please let me know.